Welcome to the Astro Imaging Journey channel. Please enjoy the episode.
Hello and welcome back to my Astro Imaging Journey channel. And in this episode I want to revisit the asteroid because I was kind of the asteroid process using Astrometrica. I was really curious on a few things. One, about submitting the data. As you said, the information was on the website somewhere and I needed to find it if I wanted to submit data. I also want to find out just how low of a magnitude I can look for. I want to see how the data will be if I stack and align it. And also, if you remember, the observations were, the known object designators that were in red were a little bit off from the actual object. So I think that is in my configurations. And so we're going to go through a few things here to see if we can get some better input into Astrometrica and get those known objects aligned a little bit better with what we saw in the data. We're going to be using the same data I did the last time here. And yeah, let's see if we can get some better results and see just how low we can go, as some people like to say. And yeah, so let's get into it. So as you can see here, we got the Minor Planet Center website up, and I've already gone ahead and got a few tabs open here. And you can see here, if we go to observers and documentation, and then you have documentation, and then you have the astrometry guy or astrometric guide. It brings you up this page here, which is, they call it a guide. A lot of people would more commonly refer to it as an FAQ, or frequently asked questions. And there's a lot of good information in here, but the main ones we want to focus on, I already have in the tabs here, is I don't have a code. How do I get one? And if you remember the last episode, I mentioned what we needed to put in in that file, that MPC file. Apologies, I had an alarm going off. So I had mentioned that there was a lot of information we need to put into the MPC file at a minimum the first time we submit data. So in here we've got a good time. It says right here, first time you submit, make sure you have this information. And I got them all bulleted here, and how to put in like your lat and long and all that good information. So that's item number 13 or question number 13 on that guide page. So I will be bookmarking this to make sure when I do submit the data that I'm going to have first set of data correct. And then on this second one, I have here, how do I begin? So the key thing here is, I was reading through it, right here it says, in your initial batch, please submit astrometry of objects fainter than 14th magnitude. So they don't want something that's really bright or really dim. Well, obviously, if it's too dim, we can't see it. But you need to be able to, apparently be able to see objects that are at least 14th magnitude or fainter. So if we remember back to the episode where we did this, we were getting magnitude 16. So we're definitely good there. We'll definitely be able to report on lower than 14, but I wasn't sure how low I could observe. You know, could I see the 20s or the 18s? You know, the 16 appeared pretty bright, but I'm hoping that with calibrating those frames, we'll be able to better determine just how low I can observe. So let's go over here. We're going to use the same data set, except this time I'm going to use the luminance data, since that should offer us a brighter or better signal to noise, for lack of a better term. And the first thing I want to do is I want to go into Astrometrica and pull up the settings. So aside from the site location, the lat and long, I'm going to double check that, but I'm pretty confident that what I have in there is good. Our focal length is still 1928. I haven't changed that from when we did the manual the last time. But what I was curious about, if you remember here, I had start of exposure and my offset was -5. And I looked at the FITS headers, and let me pull one up here. So if I pull one in, let's go. I'm going to look at the very first one here. And as you can see, the timestamp in the file is 2137, so that's 9:37 Eastern. And if we come up here to the FITS header, and we're just going to scroll down just a touch, and there we are. So our local observation date and the timestamp. But we also have the observation date in UTC already. And that one already has the offset configured for us. So in this particular one, we're going to be looking at when I load the image, and I'm going to go ahead and do that. Is it pulling this time or is it pulling that time? So I'm going to go ahead and I'm pretty sure it's pulling the observation time. And if that's truly the case, then I need to look at this offset being a 0. So I've already changed that. And I've also already changed to the visual band, which should be representative of luminance. So, and we know that if I come over here and look at the time this was created, so 9:42, and this is 9:37, so 21:37 is 9:37 to 9:42. So the file was created 5 minutes after this time, and so this is a 5-minute sub. As we can see here, it's 300 seconds. That's 5 minutes. So that would make sense. And since this time here matches this time here, this tells us that in the FITS header, time that it's recording is the start time of the image, which would, or its start time of the exposure, which would match this time and file header setting. So hopefully I have all that corrected. The only other thing I did change was I changed the color to maroon, because there's one other thing I found in Astrometrica that might help us, and we'll get to that here in a minute. And when I did a quick test, the red didn't show up too well, so I'm hoping the maroon looks a little bit better. So the first thing I'm going to want to do is I'm going to load up my process icons for my normal LRGB pre-processing, because we're going to want to use the calibration and the star alignment. We're going to want to use our darks and our flats to calibrate these images. So I'm going to go ahead and I'm going to add them in. Then we've got a working directory. Now here I'm just going to go ahead and just going to use my normal directories I keep up here. And we've got our master dark, 300 seconds, so that's good. Our master flat, so this is for blue. We're going to want to change that to luminance. And luminance. And we're going to go ahead and apply all. Okay, so that has completed. 8 succeeded. We don't need to cosmetically correct. We don't have that many hot pixels. Don't need to use the subframe selector. We're not stacking these, so we don't need to know which one is our best frame. We just need to do an alignment. So I'm going to go ahead, and it really doesn't matter. So I'm just going to go ahead and select a file for my reference image. I'll go into the calibrated frames, and I'm just going to select the first frame. We'll go ahead and we'll go ahead add our calibrated images here. Set our output directory to registered. Registered luminance, select. And the rest of this we can leave as default. It's the normal data types that we're using. So we'll just go ahead and apply global. All right, that has completed. So we can close this out. Now if we go into that directory, we'll notice that all of these, I didn't need to generate the drizzle data, but that's okay. These are all in XSIF format, which is not readable by Astrometrica. So we need to convert these into FITS format. They're in older versions, and you can go into PixInsight and set your default preference for file type. However, XISF is what PixInsight will save these as effective version 1.85, I believe, on some of these processes, because that file format can handle the data load that PixInsight puts into these things. So there is no way, if we go back into star alignment, there used to be a way to set your file extension in the star alignment process, but somewhere around version 1.85, I believe, according to the notes, that was removed, and it only saves in XSIF format. So, but we can convert this real quick if we come up here to script, batch processing, batch format conversion, and we can add our files right here. So we'll go into calibrated, no, we want registered luminance. We'll add them in here. Now these input format hints were not raw and we're not CFA, so I'm just going to leave that blank. I was saying XSIF and it's not, it's XISF, so I apologize for that. But I'm going to change the extension to .fits. I'll set my output directory. I'm going to change it over to the O3 directory just for this instance. And we'll click OK. And there we go. It's all converted. We don't need to do another one. So if we come over here to O3, there we are. They're all in FITS format. So now our data set is calibrated with the darks and the flats, star aligned, and converted to FITS format. So let's go into Astrometrica and let's load those files. And make sure I'm in the registered O3. We'll just go ahead and open them all up. And here is our time. So this reads the FITS headers and pre-populates this information. And we've got, and it's mid-exposure, so midway through. So we know it was 9:37 Eastern was the start, +5 for daylight savings. Gets us to 2:37 for UT for the start. It's a 5-minute exposure, so add 2.5 minutes, and there we go. 2:40:11. So that offset, it is reading that UT time that was in the headers. So that probably played a key factor in why those known objects were a little bit off. So we'll go ahead and we'll do an OK on all these. Now they're all in there. So let's go ahead and go up to astrometry data reduction. That was all pre-populated from the FITS headers, so we'll leave that as OK. Now, my angle in the settings was already set to 178.9 degrees, and the focal length was already set to 1928, I believe. So if this works, we should not have to do the manual adjustment, but we know that if this was a completely new data set, we would probably have to adjust those two settings to make sure everything is able to plate solve. So once this completes, we'll be right back. Okay, that has completed, and as you can see down here, we've got our data reduction results window, which means we were able to plate solve. All our settings are good. So that's awesome. So now if we come up here to known object overlay, and let's see if we are on in regards to some of these objects, or at least the one, and I believe it was over here. I want to say it was this one, but we'll blank it afterwards. Okay, that has completed. So you may notice one key thing. I mentioned earlier that I had done a quick test last night. I went back to the original data. I just wanted to tweak the settings. I wanted to see if the objects would get a little bit closer, and they did. And also I read, if you notice, we now have a grayscale with black stars. So this little button right up here, invert image. So this is what we were seeing before. And if we click that, I think the gray background with the black star or black objects and stars, it may be a little bit easier to determine, and this was a trick I learned in one of the other videos I was watching. So, but that one was, I think, 5 or 6 years old, and it seemed to work pretty good. So, but I hadn't gone in and registered and calibrated my images, so I was using the original data set. When I decided to do that, I decided, hey, let's do a revisit video and let's see if our data looks if we can look for better objects. And the maroon definitely shows up better than the red did last night, so that's good. So chances are I know my cursor has the yellow halo around it, so I'm going to try to move it. This object right here is the one we were looking at before, 02220 with a magnitude 16.2, and as you can see, it's almost right on top of it, so we're a little bit better. So maybe my lat and long is a little bit off, so I will try to get a more fine-tuned set of data coordinates to plug in there the next time I do this. But if we blink this, so it's this little rolling die icon right here, and yes, you can see that one is moving with it. That was a 16.2, and it does show up a lot better with the inverted image. So now the trick's going to be, I can't maximize this window for some reason, so we'll have to resize it. Yes, I can. Excellent. So we've got one down here. It looks like it might be pretty much on top. That's an 18.6. You might be able to see one right here to 19.3. Whoops. Did not want to click. Let's zoom in. So we know we're pretty close. If I come up here, we know we're pretty close on our observation, the known object now. So if I just come up to the corner, let's do this systematically. You see one right there. So if we stop this when it comes back on, there we go. And there's one right there. We'll be able to see it fly out of frame. There it is, and it is following it, so we'll stop. And that's a 19.6. There it is. We can click on that one, and it found it. It's pretty close, and a 19.6. It's pretty awesome. So we'll do that, and we'll do an accept. Let's go ahead and look to see if we can. It's kind of hard to see that one. This one can kind of see. That's listed as a 20, so let's see here. It's about right there. Yep, I can see the shape there. We'll find that one, and that one's a little bit, yep, we're good there. That's a magnitude 20. That is excellent. So we'll accept that one. Now if I scroll over, and I just want to find some data sets that I can plug into NPC's database like I did before, see what they say the magnitude is. So let me find a few more and we'll be back. Okay, that has, I've completed looking at all the known ones, but as I was going through, I was also just pausing ever so often and looking at just areas like this just to see. Don't see anything moving. So, you know, just taking a little thing like there's this one here. Do we see anything else moving in here? You know, just kind of doing a grid pattern as it's blinking with my cursor. Just to see, you know, that gives me the focal point for my eyes to follow. And just to see if we see anything else that it didn't find, which I didn't see anything. So that's okay. We'll stop the blink. And now there's one other thing I haven't tried yet that I'm kind of curious on. If we go here, moving object detection, I'm not sure what that will have. So let's see what that yields us. Okay, that's interesting. No moving objects detected. But we know we have moving objects like this one right over here. Or was it this one? Either way. So I'm going to have to do some research on that one. See what that does. But for now, let's take a look at the MPC data. Alright, so we've got our objects that I saw, and as we can see here, magnitude 20.6 is our faintest, 16 was our brightest. So let's copy that into another notepad. There we go. So now we're going to go back over to Minor Planet Center. We're going to go to Observers, Other Services, MPC Checker. And we know our observation date is the 19th. And our time, or wait, 2020-11. And then it's this one. Apologies for that. And then our RA and DAC. We'll copy that. Put that in there. Guess I could put it in here like I did before, but that's okay. Produce list. Okay, that came back. And it's kind of interesting that Astrometrica gave us that designator, but that designator is different. That shows a 19.7 and I show a 20.6. So that one is questionable, but like it says right here, they're quick look positions for identification, not the rigorous comparison of observations with theory. Okay. So let's move on to the second one. Let's see if that one matches up. I'm also kind of curious. So this is the one we were doing the other day. Let me just copy this whole thing here. There we go. So now this one, we'll plug this information in. Let's produce a list. All right, there we are. There's our first one. 16.2. We have 16.1. That's our most likely object. So that's pretty decent. Check a third one. Actually, I'm going to do this. If I click on that, and I produce list, does that do anything for me? Oh, that is so much nicer. So there's our Hicks based on this entry. And based on this entry, first one, 38384, okay. Magnitude 18.6. I showed an 18.8. And 7949. Magnitude 19.5. This is 19.3. Just thinking out loud here. Can't confirm that this one would be the same, but it looks, I mean, based on the position, RA and deck offsets pretty close. Magnitude 19.6. This shows a 20.2. Okay, 3662, which doesn't have the K, but that's okay. So magnitude 20. We saw 20. 6236, 6232. Okay, so maybe this is a numerical equivalent of the P. This is a 20.3. So I can see down to 20s, or down to the 20. That's pretty interesting. 9166. Magnitude 20, magnitude 20. None of these need extra data, but if you saw, if we go back here, where was that at? There it is. You know, we need objects fainter than 14th magnitude. Well, we can definitely get below 14th magnitude. We can see down to 20 with my data, with my setup. So even though they don't need the data, I can still submit the data and make sure that what I'm doing is right. That's more data points for them. They say they don't need it. I'm sure they wouldn't not take it. But it is pretty nice that we can go and just plug that information in there. That's pretty neat. So I will probably go back and double check my GPS coordinates to make sure that what I have set in Astrometrica is spot on. But we did get that a lot tighter as far as the known objects overlay. So that was much better, and that was, I think, basically that time offset. So out of curiosity, I say, what if I wanted to look for targets for a couple days from now? So today is the 1st of December. My next clear night is going to be the 3rd. So let's say the moon wasn't going to be in play. I could use my luminance filter and the clouds. So let's look here. Where did I go? I believe it was other services, observing target list. Yes. So I can plug in my Latin long here. Say the 3rd, and what hour, that's going to be UTC. What hour am I going to start imaging, and the duration. How many objects maximum, what's my minimum altitude, all that good stuff, and the type of objects. So I've already done that over here. So as you can see here, if on the 3rd, starting at midnight UTC, which would be 7 p.m. Eastern, and that would be roughly the start of my imaging time. So let's say I want to dedicate a whole night just for asteroid hunting. I just want to point at one point in the sky and let the telescope just follow. And what would be the starting object I would want to look at? And it could be any of these. We've got a 14.8 and down to a 17.4. Let me scroll down. We got all the way down to a 19.6. So any of these objects I would be able to try and find. There's a 20.4. So, yeah, we could point at any one of these. Let's scroll back up. So there's our begin RA and deck. We could plug that into, say, Sequence Generator Pro. That would be our beginning RA and deck at that particular time, and let it slew over, center, start taking images, and I think I might actually do this one night. I do want to submit, sorry, scroll moment. So I do want to do this at some point in the future. Right now, moon, we just had the full moon yesterday or the day before. So for me to be able to use the luminance filter, it's going to be a couple weeks. So what I might do is I might go out there tonight, or today, double check my GPS coordinates, go back into Astrometrica, make sure everything is right. As you saw, we had, what was that? Looks like 368 known objects that I can put the data set together for, submit this data so that I'll know if what I'm doing is right for their data sets, and then I can come back once I know, because it might be a couple weeks. You know, we don't know how long it, or I don't know how long it's going to take for them to review a data set, but I'm going to use this data. I'm going to create a data set. I'm going to submit it, see if they accept it. If they don't accept it, hopefully they tell me why it wasn't accepted and what I can do to improve it. And then once I know what my data set needs to look like and what I need to do, then I'm going to come over here. I'm going to look at a particular night. I'm just going to dedicate one night, and let me load up Stellarium. Okay, so we're in Stellarium now. Let me go ahead and where's my date and time window? Let's get to about 7 o'clock. There we go. This will be on the 3rd. That's the date we searched for. I'll look east and need this RA and deck. Search, we're going to go to position in the search window. Hours, minutes, seconds. I don't know if we need the M, H, M, and S, but I'm going to put it in there anyways. You can see it tried to slew over. Need the degree. Will I accept that? No. And not exactly sure how to put that one in there. We are at minus 842.30. Minus 842.30. Okay, so I know why I was having trouble. In the longitude, I did not have the negative set since I'm west of the meridian, or excuse me, west of Cambridge, Greenwich, whatever you want to call it. So let's look for flora, 8 flora. F3, flora, it's not in there. Okay, so if we do a position, and we do 2, 17, 44, 7, and we're plus 3, plus 43, 11. And there we are. That little patch of sky is where that asteroid should be. That is not Eros, by the way. That is on the other side of the planet right now. But we should be able to plug those coordinates into SGP, create a starting set, and follow it. Now, it's high enough. I would probably prefer something down this way, but it is what it is. Let's go back to the targets. That was our first one. That's a magnitude 8.8. We don't need to do that one. So you can see all of these magnitude 13 or better. Okay, so I put 100. I was trying to do 200 to see if I could get something a little bit fainter, but maximum 100. And I changed it to near Earth or asteroids. And as you can see now, we're getting fainter ones. So aside from the top one, the rest of these should be visible. Let's take the first one here, Alinda. If we search for Alinda, is it already in there? No. If we do position, it's that top one right here. Do 4, 13, 51, 7. And 24, 36, 49. Okay, so that's at 720. It's still right behind the trees. So it would just be popping out, probably viewable around 730. So what I'm getting at here is we can look for the known objects that, or we can look for in the database for an object to center on. And what I want to do is, this is a good target to start with. Alinda, it's a little bit brighter, but there's probably other ones in the area. And I can set up SGP to look at this patch of the sky and then let it just follow through. If we go, and because I want to do a wide field as well, I'm going to mount a second camera onto the top like I did before. Looks like our meridian flip's going to happen around 11:30. That's good. I should still be up if this was the day. And bam, it would take me to about 150, 145, somewhere in there, before it starts hitting the trees, and they're a little cut off, so probably 130-ish. Yeah, they're pretty cut off. But what that's going to serve a couple purposes. One, I'm going to be able to capture about 4-5 hours worth of data on one little patch of the sky. I'll be able to get a lot of data sets, hopefully, on asteroids in that area or in that patch of the sky. And then I'll be able to do my wide field that I'm hoping to do some type of a slideshow to show the Earth moving underneath the night sky. We'll get into that one if I can do it. And I think the star trail videos that I've done before, where the stars are moving, that's at the beginning and the end of my videos. But instead of being stationary, I want the I want to show the transition. The sky is the stationary point, and the trees and everything moving underneath. So we'll see how that one goes. But this would be pretty cool little thing to do. Might be a little bit more dynamic if I can point a little bit more south, but thinking out loud here. But this will also serve a third purpose of me testing out some things with the meridian flip. I want to see about setting up a second target or letting it just do the meridian flip, because the meridian flip's going to happen about 11:30 on this particular night. If this was the night I was going to do it, then I'd still be up and I'd be able to monitor it and see how things were going. But when it does come time and the moon is, I don't like to do luminance RG or B unless the moon is pointing in the other direction, 90 degrees off and 50% or less, preferably 30% or less. So yeah, I'm thinking it's going to be a few more weeks before I get to it, but we will definitely see what we can do. And the Astro Imaging channel, TAIC, is doing a challenge, or not a challenge, but they're doing another I can't think of the word right now, collaboration, where they're asking people to submit things in the Orion cluster. So this one might be kind of unique. They did it with Neowise, where they asked everybody, go out, take pictures of Neowise, put it, submit it to them on Facebook and others avenues, and they would take all that and they created a slideshow, movie, whatever you want to call it, and presented it both on their live channel the one evening, as well as via Facebook and their website and other social media. They put all the submissions together of everybody's Neowise images and slideshows and different things, and gave each imager credit, and you get to see different perspectives, different editing techniques, different things. They didn't go into everybody's processes. It was just, but you could see the subtle differences where somebody, it looks a little bit different in perspective when you got somebody going from a mountaintop and it's prominent in the sky, and then you have somebody else that's another part of the country or world, and this time they're shooting it and it's just above a tree and they're shooting it from closer to sea level, and just the different perspectives, the different thought process. You can just see the stuff that goes through their heads sometimes. And in this particular case, I'm thinking if I can find an asteroid as my starting object, and it is in the constellation Orion, and I can put together a slideshow that would show the transitioning sky, or rather the transitioning Earth's surface underneath the stationary sky, and then in there, maybe in the corner or somewhere, every time I find an object in these data sets, I can put a little transitioning object down in the corner, and that would be, I think that would be pretty cool. And that would be my submission, something a little bit different. Let me know in the comments what you think, if you'd like to see that. If you would, I'll do a video of it. But yeah, let's get back to, but the meat of this one was a revisit of our original data. Did it work out for us? Yes. The key takeaways here: calibrate your data, align your data, import it into Astrometrica, invert them so that you have the gray background and the black objects. That definitely helped me. And and making sure all of your settings are right and understanding what those settings are. The key one here being, make sure your lat and long that's configured is as close as possible, and that check the information in your FITS headers if you're using FITS files. Is that time in the FITS headers the start time or the end time of the frame of the exposure? And is it already in UT time, or do you have to put in that offset? Validating all of those settings, and then redoing the process or the evaluation on the same set of data yielded known object indicators that were much closer, and in a couple of places almost right on top in the data, which was awesome. And inverting the images and having cleaner images through the calibration and star alignment just made it so much easier to identify not just the one that I initially saw, but now I can see others, and that was pretty interesting. So now it almost makes me want to go back to some older data and look at that information as well. But for now, I've got a couple targets that are almost to be completed, so I got a few other things I want to do for some videos first. And like I said, we've got a couple weeks before I can get the data set. So I'm going to go back. I'm going to redo my MPC data. I'm going to try to submit it and see if it gets accepted or rejected, and we'll go from there. But with that, I'm going to say thanks everybody for watching. Hope you found this beneficial. Hope you're staying safe and healthy out there. As always, clear skies and have a good one.
Thank you for watching yet another video from the Astrometry Junior channel. Really appreciate your viewership. In our upper right, we have the latest video we've uploaded. In our lower right, we have what YouTube might think you would enjoy. And in the lower left is our subscription button. Please like this video, subscribe if you so choose. As always, clear skies, have a good one, and remember Duke.